Joanna Simpson here at QuantMinds International in Barcelona. Joining me now is Christian Kappen, Manager at Define. Thank you very much for joining me today.
Thanks a lot for having me.
And just tell me a little bit about how you're experiencing the conference so far.
Well, I'm greatly enjoying the conference. I'm enjoying the opportunity to talk to my peers, to have interesting and inspiring conversations. And also there were a couple of talks that really changed my perspective. So I'm going to take those ideas away and probably implement them in one way or another. So it's been very inspiring.
Oh, very beneficial so far. That's
Indeed,
great.
yeah.
And how do you see the future of machine learning in risk and pricing?
So I do see machine learning as a potential tool in risk and pricing with great potential indeed. Let me mention two possible applications that I see. So one being refinement of classical models, where techniques such as the ones called deep hedging can be used to actually solve pricing equations for highly intricate, complex models, taking, for example, complexities such as transaction costs into account. So the other application I see, and that's the one that I've been focusing on so far and that I also gave my talk upon, is acceleration of classical models. So model acceleration is a big topic. It's a vast topic as well and has been an active area of research over the past couple of years. So classical techniques such as Chebyshev polynomial interpolation have been explored, but also machine learning techniques such as deep and shallow neural networks. So in combination with dimension reduction techniques such as principal component analysis and tensor networks. So what these, let me call them fast models or fast prices in certain instances all have in common is that they are really approximations. So this really enables people in the industry to strike a balance between speed and accuracy.
And what opportunities have you found when delivering client projects on machine learning in risk and pricing?
So we recently conducted two pre-studies with our clients, both centered around acceleration of prices for Bermudan swaptions in value at risk settings. And the results have been quite promising indeed. So we achieved significant speed-ups while at the same time seeing very good accuracy, in particular in the loss tails of the P&L distribution where the risk is located. So one of our clients has decided to enter into an extended parallel phase. So certainly see the opportunity for that client to speed up the value at risk computation, to be able to do intraday risk analysis, which is certainly not possible using a full revaluation. So that's definitely an opportunity.
What have been some of the challenges?
So I mentioned that good accuracy has been achieved. I would say the main challenge is to actually sustain that accuracy over time. And one way to address that challenge, in my opinion, would be the design of a sound model lifecycle process, taking certain specificities of machine learning into account, like retraining triggers. So one should have automated processes to indicate when a model should be retrained, when the market has moved, or when the portfolio has changed, or when the pricing function itself has changed. Then ongoing monitoring is essential based on benchmarking against an explainable reference model. And also validation techniques are very important. So in that setting, I believe that actually classical model validation techniques can be leveraged also to deal with machine learning models. And all in all, I believe that those ongoing controls and those validation techniques can also help address another challenge, that of explainability, which will be a focus of supervisory scrutiny, most likely. So I do believe that having a sound process around a machine learning model can greatly help address that challenge as well. And either way, I would definitely recommend, before going live with such a model, to test both the method and also the processes around it in an extended parallel phase.
Christian Kappen, thank you very much for your time.
You're welcome. Thanks a lot.